The next thing we're going to be looking at is factoring a difference of squares. So we've talked about factoring polynomials with four or more terms. We use grouping. We talked about factoring trinomials with three terms, where we looked at when the coefficient of the square term was 1, we did one technique. When it was not 1, we did a different technique. And now we're looking at polynomials with two terms, binomials, and we want to be factoring. We're going to be talking about factoring the difference of squares. The idea here is if I have a plus b times a minus c, when I FOIL here, the first terms are a squared, outer terms would be a negative ab, inner terms would be a positive ab. Those would add up to 0. And then my last term would be minus b squared. So I get two squares, a squared, b squared, and there's subtraction in here. So this is always going to factor into exactly the same binomial, except they're going to have opposite signs. So if a and b share no common factors other than 1, then the sum of squares a squared plus b squared is not factorable over the set of real numbers. And always be sure to factor out the greatest common factor first. So basically what you do is if you got a difference of squares, first of all, make sure they're perfect squares and make sure there's subtraction. If so, you take the square root of the first term, square root of the second term, you take those answers, a plus b and then a minus b. So if I've got this first one, perfect square, subtraction, a here is going to be x, b square root of 25 is 5. And so now I'm just going to put it into the formula. A plus b and a minus b. So it would be x plus 5 times x minus 5. And that would be the factorization. Let's try this next one. And I'm gonna change it a little bit. I'm gonna make it a little bit more interesting. Let's make that a 9x squared. So I'm changing the problem, but you know me, that's what I do. So now a here would be, the square root of 9 is 3, so this would be a 3x. Square root of 1 is 1. We do have subtraction in between. So now we're just going to go write it in. And my 3x's here. And my 1's here. All right, let's try the next one. So here, a is going to be m, b is going to be 7, and now we're ready to go. So a question comes up, does it matter if I put the plus first and then the minus? Or can I put m minus 7 then n plus 7? And the answer is no, it does not matter. It doesn't matter which order I write those in, so long as that one of the factors is m minus 7 and the other factor is m plus 7. Now this is almost exactly the same thing as this one, except when I do my b here, b is going to be a 7n. So when I write this out, it's going to look almost exactly the same as the last one, except I'm going to have a 7n for the second term of each binomial, and this needs to be a subtraction. My bad on that one. So it would be n plus 7n in parentheses times n minus 7n in parentheses. Now for number 5, we can't break that down. That is a sum of squares that cannot be factored in real numbers. So we'd say this is prime. Now be careful here. You might be tempted to say, hey, that's 3a, that's 9, and you might be tempted to write this as 3a plus 9 times 3a minus 9. And even though that does factor into that form, if you type that in ALEKS, it'll be wrong because it's not completely factored. These still have some common factors here. So what you want to do here is first factor out the greatest common factor, which in this case is 9. That's going to give me a squared minus 9. So my a value is going to be a. That's kind of weird, right? My b value here is going to be 3. So my 9's out in front. And then we're going to have a plus 3 and a minus 3. So that's the way you want to do it. Also just note, if I factor out a common factor 3 here, factor out a common factor 3 here, I get 3 times 3 gives me the 9. It's just a lot harder to extract that than if you get the greatest common factor first. So here at number 7, again, I want to do the same thing. Get the greatest common factor first. So I'm going to factor out a 4. X squared minus 9. And now we actually kind of did it up here, right? It's the same thing, except it's an X instead of an A. So my 4 is going to be in front. And we're going to get x minus 3, or sorry, x plus 3, excuse me, times x minus 3. Now here, you might say it's sum of square, it's prime. You might want to write down that it's prime. Well, guess what? ALEKS would say it's wrong because you can still factor out a greatest common factor of 25. So we could take that 25 out. That gives us p squared plus 4. And then it's the p squared plus 4 is prime. So you are actually able to do some factoring. All right, let's look at number 9. It says create your own difference of squares problem. All right, well, let's have some fun with this. Let's go ahead and let's do this. I need a perfect squared, so I'm going to do a 4x squared. And I need another perfect squared. Well, 11 times 11 is 121. And let's make it more interesting. Let's make that a y squared. And then I need subtraction. So my first here, or my a here, would be 2x. My b here would be 11y. So that's going to factor into 2x plus 11y times 2x minus 11y. All right, next one says create a sum of squares that is prime. All right, so again, I could use the same example, right? I could do 4x squared, 121y squared, and I could just put a plus sign in front of it. And there it is, it's prime.